Okay. All right. So if cosine and secant are even, then sine and cosecant are also odd. Um, well, that's not maybe as obvious, but that is true. Sine and cosecant are odd. One of the ways you can tell is sine of 0 is 0. That's if it goes through the origin. Cosine does not go through the origin. In fact, cosine of 0 is actually 1. So it doesn't go through the origin. That's how you can tell it's not an even. I'm sorry, not an odd function. Anyway,
Wait,
so I
don't
kind of
erase.
what's that?
Don't erase.
Don't
Oh,
erase. Okay. All right. Um,
okay, I'm good.
okay. So I wanted to show you that, as you can see, each of these um, could be their own separate function, right? And so adding or subtracting a whole bunch of even functions, it stays even because what matters is what's happening in each of the separate functions, whether you're adding or subtracting them. Multiplying and dividing can be a little tricky. Let's not get into that. But certainly, if you have a bunch of even functions added together, it stays even. So I wanted to show you some of that. So here I have this silly function here where it's an even power of x and then an even power of x. X to the 0 is even. And then a cosine. And as you can see, let's see, which one is this? Yeah. Um, it's an even function. It's perfectly symmetrical around the y-axis. Um, now I wanted to. uh-huh, uh-huh. Um, there's also an example of a fun little odd function that I made. Um, whoa, somebody's kind of loud here. All right,
Sorry, it might have been me.
it's okay. So here's an example of an odd function. So I put together a sine function, which is odd, x to the 1 and x to the 3. These are all odd functions, and as a result, you get an odd function adding odd functions together. Um, and one of the things we talked about was that if it's odd, then from taking the integral from negative a to a gives you 0. And we were talking about how the reason why is because you are mirrored across the y-axis, but wherever you have a positive on one side, you have a negative on the other side. Let's look at a little bit more of the algebra of what's going on with that. Um, so um, so one of the things is if we're starting with f of x being odd, and if f of x is odd, then that means f of negative x equals negative f of x. Um, so you could probably get it just from this because remember, if you're doing the sum of all the rectangles, remember, um, and it's let's say from negative a to a. I know this isn't quite right. It's always from 1 to something, but we're kind of taking a shortcut here, mixing together some things, some ideas. But if you can picture this, what's going on is that um, you've got your positive ones will be over here, and then all the ones that are on the other side will be the negative version. And I know I flipped that around. Um, okay, so here's let's say f of 2, and this is f of negative 2, and it's the same as negative f of positive 2. So this rectangle here, or let's maybe do red, is just the negative version of this rectangle over here, and that's true for each one. And so no matter what you do, if the whole function is odd, every single box, if you're going from negative a to positive a, every single box will have a partner that is the opposite sign, and so it'll just add up to be 0. But the other way to see this is that, remember we're doing actual integrals here. And so let's say this is x. Let's call this 3x squared just to use an example. This is an even function. What is the integral of 3x squared? Anybody?
X cubed.
X cubed. And what are we evaluating it from?
From negative a to a.
Negative a to a. So we put in a cubed minus
Negative cubed.
Oh. Okay, it's odd. I'm messing with myself. Yeah. Okay, let's start this over. Sorry. Yes. So let's call it 4x cubed then. If we're going with an odd function, right? Then the integral of that is x to the 4th. And so we have a to the 4th minus negative a also to the 4th. Notice what happens here. The odd function, and this is why I got confused, the odd function here has an even antiderivative. And you can see what happens here is the negative in this a here, when it's raised to the 4th power, you just get a to the 4th minus a to the 4th. And so there you have it. That's 0. Okay, so all that is an explanation for why. And as you were perhaps noticing, let's do the other example. Sorry. This will be recorded, so you'll be able to go back to it if you missed something. The other example is if we were doing from negative a to a of, let's say, well, we were doing 3x squared, right? This is an even one. I'll make a little chart in just a second of the actual. Here's how you do stuff. Here's the even example. We were saying that's remember it's x cubed from negative a to a, and so you get a cubed minus negative a cubed. But because it's cubed, this negative, there are 3 of them, so they stay, and so you get a cubed plus a cubed. In other words, 2a cubed. And this is always going to happen. It's always going to be something minus the negative version of itself, and the negative version is going to make it a plus. So instead of 0, as we can see here with an odd function you get 0. With an even function, you get with an even function you get twice the result from 0 to a. So in other words, from 0 to a is mirrored on the other side, 0 to negative a. You can just get 2 of them added together. So all that was sort of to get to this idea of, if you want to know how to calculate things, if you have from negative a to a of f of x dx, then if you have f of x odd, then the answer is 0. It's just that straightforward. The answer is just 0. If f of x is odd, then from negative a to a, the integral will just be 0, always. If f of x is even, then what you get is 2 times, 2 times the integral from 0 to a of f of x dx. Because they're the same on both sides, so you just count what's the one side. That this will be easier to count because you're subtracting 0. Just do the one side and then multiply by 2. And that's what you get. So this is super helpful. I recommend writing that down. And I will get to one of the immediate applications here. Yes, let's do this one. So if you remember, we you can split apart integrals in however you want. So if you have let's do the integral from -3 to 3 of 5x to the 6th plus 7x cubed minus 10x minus 6 dx. Now, this already looks like a pain, and it is. But because we're going from -3 to 3, there is this trick that you can use. Let's split this up into 2 integrals. We can always do that when there's pluses and minuses. And let's gather all the odd pieces and all the even ones into separate things. So which of these are even powers?
The 5x to the 6th and 6, -6.
Yeah. Okay, so 5x to the 6th minus 6 dx. And again, it's from -3 to 3, but we're running out of time. Okay, and then what are the ones left over? Well, if they're not even, they're odd. And so here's to the 3rd power and here's to the 1 power. These are odd ones. 7x cubed minus 10x dx. And again, we're only doing this because it's from -3 to +3. That's the only time this trick works. Okay, now we have the integral from -3 to +3 of an odd function. So what is this equal to?
Oh, 0.
0. Remember, because with the odd ones, they're alternating. You have a positive and negative that will always cancel each other out. So because we're going from -3 to 3, or from -19 to +19, because this is an odd function, it will be 0. And this one is 2 times the integral from 0 to 3 of 5x to the 6th minus 6. Okay, so we went from this to this, much easier. And let's actually calculate that out. I'll make a little bit of space for myself. Again, I'll have this recording up so you can go back and look at it if you missed something. I'm sorry, we're running out of time again, as usual. Okay, so anybody want to help me on the actual details of this here? We have a 2 up front. This would be
Oh,
the
1/7 squared. Oh, yeah.
x to the 7th. I'm just putting the 5 on top. Minus
6x.
6x. Evaluated from 0 to 3, which is nice because, especially since 0 is the second one, because then we just have to do 5/7, 3 to the 7, minus 6 times 3. And then it's minus 0, right? All these terms have an x in them, and so that's just 0. So that's how we took this whole big thing, and there is a shortcut because there are positive and negative bounds that we're dealing with, and we use both different shortcuts. But even if we could just use the one and just drop half the integral, that made our lives a lot easier. All right, so I really think that we're just going to work on the homework that is due today, that I put up yesterday. That's I don't really know that I'm going to add to that. In fact, I'm pretty sure I'm not going to.
Yeah,
You're welcome. You guys have enough to worry about.
Thank you.
We are next week. We're going to get into some things that are a bit less. We're still going to be doing integrals, definite integrals, but we're going to be doing other stuff. We're not going to do more symmetries and things. But anybody still confused about symmetry yet? There's a lot going on, I know.
I think
Any questions, or everybody good?
I think we're good.
Yeah, I don't have any questions.
All right.
Bye.
Well, bye. I will see you next week.
Bye.
Bye.